In an open-world video game like this one, the player can interact with a wide range of objects. To enhance realism, multiple clips are used for each impact sound, but the resulting variation comes at the cost of increased memory consumption. We present several techniques for synthesizing sounds that can enable a wider range of variation and reduce memory consumption. Original source clip, we compute a spectrogram, which shows the frequency content of the clip over time. From the spectrogram, we identify peaks in frequency corresponding to resonant modes. The values for the modes can be stored quite compactly. We sinusoids associated with each mode and sum them up to obtain the modal component of the sound. Subtracting this from the original clip produces a residual that consists mostly of noise. The residual is often quite short and can be clipped, resulting in significant compression. Modes decay over time. Interactive modal synthesis techniques assume exponential decay, which is linear on this logarithmic graph. We use the actual amplitude envelope for higher accuracy. Our modal synthesis can represent a variety of sounds. We simulate the variation in sound obtained by hitting an object in different locations, by randomizing the amplitudes of each mode. Here's the original sound and several variations. Modal synthesis is less well suited for sounds with frequency spectra that are more broadband, like this footstep. For these kinds of sounds, we obtain variation by using a filter to randomly attenuate regions of the spectrum. Here are results for modal and filter-based variation. We demonstrate these sound synthesis techniques in a video game. We start with a pickaxe sound generated with modal synthesis from a single input clip with no variation. Pressing the modes adds some subtle variation to the sound. Tutorials use multiple clips for additional variation. Can be limited by fixing a mode quota. When the quota is exceeded, we drop low power modes for graceful quality scaling. The following examples apply the variation filter to a single clip.